Welcome to example 16, and in example 16 we have two tasks here. We have A, what is the required diameter if its unit stress may not exceed 24,000 psi, and B, what is the required diameter if its elongation is not to exceed 0.005 inches. So we start with A. Come down here, A. So we want to find the diameter of this steel rod here, given this. If F max equals 24,000 psi. And, well, what equations do we know? Well, we know a few. Since we're dealing with tension or compression, we're dealing with tension, so we know this. We know delta equals PL over AE. And we also know that stress and tensile stress equals P over A. So you ask yourself, okay, well, that's what we know the equations are that we can use. What do we know? We're looking for the diameter. We know F, so we'll have to plug in F right here. And we know P. Alright, so if we know F and we know P, we can get A. Correct? Yeah, sure, that makes sense. So let's go ahead and do that. So you say if the max stress you can get equals 24,000 pounds, pounds per square inch. I don't know why my program's messing up a little bit, but oh well, we'll work with it. 24,000 psi equals, we know P, let's go ahead and put P in there, 10,000 pounds, and then we need to solve for A. And knowing what we know about algebra, we can go ahead and just do this in our heads real quick. What you will do is you will take A to this side, and you'll take 24,000 pounds to this side, and A will go to this side. But I'm just going to do it in my head here. So we know we're going to have 10,000 divided by 24,000. Divided by 24,000 equals, so now you know, and I would say A max, or min, the minimum A you need to have equals 0.4167 inches squared. Now if you want to take this and you need to find the diameter, because they didn't want you to find the area minimum, they want you to find the diameter minimum. So all you have to do is plug this into your diameter equation, which is either pi r squared, or this is typically more useful when you're looking for diameter, is pi d squared over 4. And we're going to go ahead, and that will equal your area, which we know area, A min, equals 0.4167 inches squared. And then we have pi over here, d squared, because that's what we're solving for, over 4. Now we'll just do this, solve for d. D equals, hopefully you'll get this in algebra. If you need to write it out and take a couple steps, you can do that. But if you solve for d, then you need to get 4 over here, so it's going to be 4 times 0.4167 inches squared. And then you're going to have to take, since it's multiplying by pi, you're going to be dividing by pi on this side. Divided by pi, and then you take the square root of that, since you have d squared, because d squared would equal, you get rid of that and it would equal that, but since you're taking the 1/2, So when we do this real quick, 4 times 0.04167 divided by pi to the 1/2 equals, and this would be diameter minimum, to get the minimum diameter you want. Hopefully that makes sense. 0.73 inches. Let's see what he got. He got 0.728. Okay, 36 inches. He kind of went all crazy there. But he stopped right there. I'm not going to stop right there. I'm going to go ahead and say, okay, does this make sense? Are you going to have a diameter of 0.73 inches? No, you are not. You're going to have, and I would just, for any realistic problem, of course, you're just going to say, all right, 3/4 inch diameter. This would be the exact perfect correct answer. This would be the real world correct answer. All right, we're going to go ahead and go on to B. And I'm going to have to erase some because I'm low on room. Let's get rid of A, excuse me. And hopefully that makes sense to you. Everything that we've done so far, just remember the equations. If you remember the equations and you look at the units, you can usually figure stuff out. All right, moving on to B. And once again, they're asking for what is the required diameter if the elongation is not to exceed. So we know that delta max, let's call it delta max, so we know it's not to exceed. That's most. It can be less than that. We want to go 0.005 inches. And we're just go back to what we just did. We're going to use our equations and we're going to say, oh, okay, delta equals P L over A E. All right, and once again, I'm just going to say with this, I kind of said delta over PL, delta PL over AE, as opposed to saying this is the deformation, I would call it, or the elongation. This is going to be how much does this bar move. So if you're pulling on it, it will move this much. That's what delta is. I always remember it as deformation. I think they call it elongation once again. P is your load, your tension load, your tensile load. It's 10,000 pounds. So let's go ahead and put it in there. We know delta max, so let's put that in. 0.005 inches equals, and then we know 10,000 pounds. Then we have L. L is the length of your beam, or your bar, or whatever you're talking about. Typically it will be a bar when you're talking about tensile problems, but it can be whatever shape you want it to be. And you want it to be in inches once again, because look at your, this is your deformation is typically going to be in inches because you don't want to be in feet. That's a heck of a lot of deformation. So you want to, if you have this in foot, the L in foot, you want to change that to foot. So if you have, usually I'll put in here, 2 foot times 12 inches, and that'll work out. And then you have your area in inches, and that's what we're going to be solving for. And then E is the modulus of elasticity, which is always going to be 29,000 KSI or 29 million PSI. All right, now we have everything. We can solve for A, just like in last time. So without going through all the crazy, it's not really crazy algebra, it's pretty simple. The A is on the bottom over here, so you want to bring the A over here on the top. And you want to bring here is multiply, so you want to bring it down. And the A is going to go up. And hopefully that's becoming intuitive to you, or maybe not intuitive, it's just simple. You know it right off the hand. But you're going to have 10,000 times 24 divided by 0.005 divided by 29 million. And your answer is 1.66. And that's going to be in inches squared. Now we once again want to solve for the diameter. So let's look at our diameter equation, which is pi d squared over 4 equals a. Let's put an a over here. So 1.66 equals pi d is what we're solving for over 4. And shoot, I've kind of messed myself up here. I don't really have any room to write the, but it's going to be, we'll sneak it in over here, the square root, and let's see, 1.66 it's going to be times 4, and then it's going to be divided by pi. And we're going to take the square root of that. And the answer is 1.45 inches. And let's check that to what they got. 1.454 inches. So we're good to go.